Good morning, friends. Myself, Dr. PALANIAPPAN, Professor of Physics, ANNAMALAI University, discussing about the relativistic quantum mechanics. So, we have already seen few necessary basics in these topics. The topic being relativistic quantum mechanics is a quantum mechanical equation in relativistic cases. That we already know, quantum mechanics is for microscopic particles, and the term relativistic indicates that it is for a fast moving particle. Fast moving in the sense moving with a light velocity. So, this topic is fully pertaining to a microscopic particle moving with light velocity. For example, electrons revolving in an atom, they are moving with relativistic speed, moving with light velocity. Electron being a microscopic particle and moving in light velocity, we can refer relativistic quantum mechanical equation for an electron in an atom, in any atom. In general, the simplest atom is the hydrogen atom. So, we may frame this equation for a moving electron in hydrogen atom. Further, the electron in a hydrogen atom is not a free particle. The electron is always under the control of nucleus. It cannot go away from the nucleus. It is always under nucleus influence. That is why it is always revolving the nucleus. So, the revolving electron in an hydrogen atom or in any atom is not a free particle. It is a bound particle. We have to frame the relativistic quantum mechanical equation for this type of particle. This type of particle we generally call as bound particle. Already in relativistic quantum mechanics we have seen two equations. The very first one was by Schrödinger, correctly called as Schrödinger's relativistic quantum mechanical equation. His equation has serious defects. Of course, this is the very first equation developed in the branch, that is a grand success of Schrödinger, is with serious defects. The defects are removed by Klein-Gordon, KG, by assuming a different assumptions. That we have already seen. Just for refreshing our idea, I am briefly repeating the things. Schrödinger formulated the equation with the two steps. The first step being the getting of quantum equivalence for classical parameters, the very first step in Schrödinger's idea. The second step being implementing the classical quantum equivalence in relativistic classical mechanical equation. When the relativistic classical mechanical equation was substituted for quantum parameters, then that equation got changed as relativistic quantum mechanical equation. These are the two steps proposed by Schrödinger, and he made the things and he got an equation. That equation is having major two difficulties. Then KG have further assumed that relativistic cases need not be linear in nature. Relativistic equation need not be linear. It is a very basic assumption of Klein-Gordon. And they have used the notation del as a gradient operator, not a divergent operator. With these two further assumptions, along with Schrödinger's idea, KG have proposed a new equation. That new equation we call KG equation for a free particle, that we have already seen. KG equation for a bound particle. We have already seen that for a free particle, Klein-Gordon, KG have suggested that del square minus 1 by c square dou square by dou t square into psi is equal to m square c square by h cross square into psi. This equation is called as KG equation for a free particle. This equation we have already seen in one of our earlier sessions. And we have already seen that this equation has many defects, of which the one particular defect is that this equation is applicable only for spin 0 particles. It is not applicable for spin half or other particles. For electronic systems, as the electron spin is 1 by 2 half, this equation cannot be applied for electronic systems. Still, we are going to apply this equation for a hydrogen atom having an electron with a spin half value, and found that the theoretically calculated value does not match with the experimental values. That we are going to see in this session, and that equation we call as Kg equation for a bound particle. So, the equation given in this slide is Kg equation for a free particle. This equation is modified to get a Kg equation for a bound particle. That is the subject matter of this session. So, in this case, we have to see that what is a free particle and a bound particle. A free particle, for a free particle we can apply Cartesian coordinates is the first thing. Cartesian coordinates being x, y, z is the axis parameters. All the three values are distance, that is Cartesian coordinates. This is applicable for a free particle. And another one, a free particle has no strain. It is free, so there is no question of strain in the case of free particle. So, if there is no strain, there will be no potential energy and the energy will be fully kinetic. So, we can say the kinetic energy is fully the total energy. This is for a free particle, but for a bound particle, that is a particle under strain or a particle under compulsion, that we call as a bound particle, like the case of electron in an atom. The electron is always under the influence of nucleus, which is under which is with a strain. So, there is no free nature in the particle, it is with a strain. Being strain, there will be a potential energy, it cannot be neglected. For an electron in an hydrogen atom, the nucleus is Ze, the electron is E, the distance is R. So, that the potential energy for this case is force into distance. Force is by Coulomb's law, it is Ze into E by distance square R square into distance R. So, this is Ze square by R. This is the potential energy for a bound particle. For a free particle, this potential energy will not appear. If it is a bound particle, then only we have this type of potential energy. This has to be considered while discussing for a bound particle. This has to be taken in the equation. So, we are going with the bound particle conditions. So, for a bound particle, the case of electron revolving an atom, the first correction is potential energy should be included, should be considered. This is the first thing we have to keep in our mind. The second point is we cannot use Cartesian coordinates. Cartesian coordinates are all distances. Here, if though electron is in movement, the distance may not vary, so that the electron seems to be of no use, or the electron seems to be in rest. So, we cannot use Cartesian coordinate for a bound particle. We have to go for spherical coordinates or polar coordinates, both are same. The spherical coordinates or polar coordinates are one distance and two angles r, theta, phi. This is the correct coordinate system for hydrogen atom. The electron moving in an hydrogen atom, we have to use r, theta, phi coordinates. These are the major two changes for a bound particle. We have to implement these two corrections in free particle equation. The free particle equation is m square c square p square plus m square c power 4 equal to E square. This is the classical mechanical relativistic equation. Relativistic classical mechanical equation is this one, c square p square plus m square c power 4 equal to E square. For a bound particle, including the spherical or polar coordinates, we have to write c square p square plus m square c power 4 equal to E plus Z square by R whole square. That is, we are using the potential energy term here. This is potential energy, this is the energy term. For a bound particle, there will be a potential energy, and that potential energy should be considered. So, the equation is not E, but E plus Z square by R whole square. Now, the potential energy correction is included in this term. So, keeping this term and replacing P by minus IH cross del. This is the Schrödinger's classical quantum equivalence. So, including this correction, we have C square, instead of P square, we have C square into P square. I square is minus 1, minus square is plus, I square is minus 1, H cross square del square plus m square C power 4 equal to E plus Z square by R whole square. So, in the above equation, I have replaced P by minus IH cross del. We have this equation. So, we can write this as minus H cross square C square minus H cross square C square del square plus m square C power 4 equal to E plus Z square by R whole square. This is a general equation, and we have to include the wave function psi to make it as a quantum mechanical equation. This equation is not with psi. That correction we have to take over now. So, the equation becomes minus H cross square C square del square psi. I have included the wave function psi plus what is the equation? That is minus H cross square C square del square plus m square C power 4. This m square C power 4 into psi equal to E plus Z square by R whole square into psi. Now, this equation becomes a quantum mechanical equation. Divide each term by H cross square C square. We have the first term is del square psi plus m square C power 4 by minus H cross square C square into psi equal to E plus Z square by R whole square divided by minus H cross square C square into psi. Taking this term to left hand side, this will be del square psi plus m square C power 4 by minus H cross square C square into psi minus E plus Z square by R whole square divided by minus H cross square C square into psi equal to 0. I make the denominator as common and the negative sign is removed, so that we have del square psi, this minus and minus become plus, this plus and minus become minus. So, I am writing del square psi plus E plus Z square by R whole square minus m square C power 4 by H cross square C square into psi equal to 0. This is one major equation. This equation is in wave function, and we have to implement one more correction for a bound particle. As I told already, for a bound particle, there are two major corrections. One is potential energy correction, other is spherical coordinate consideration. The potential energy correction is already made. Now, we are going to do spherical coordinate inclusion. Spherical coordinate for a in spherical coordinates for a wave function. So, a wave function psi in spherical coordinates is given as psi of r comma theta comma phi is a 3 variables, 3 coordinates, 1 distance and 2 angles. So, we are writing psi equal to psi of r comma theta comma phi, and we have to use this type of coordinate system in the above equation. So, implementing this, or we have to implement this wave function psi in equation, but the wave function is a 3 variable parameter. It cannot be implemented as such. So, I have to make it simple as a single parameter function. So, I have to using separation of variables, using a mathematical technique called separation of variables. This technique will enable a function with many variables, we can split into many functions of single variable. So, we can write psi of r comma theta comma phi as equal to r of r, theta of theta and phi of phi. So, r of r is one function with a single variable, theta of theta is another function with a single variable, whereas phi of phi is a third function of single variable. This technique we call separation of variables. A function with three variables can be written as three functions of single variable. This technique I have used to split the coordinates in the above equation. So, we have del square psi plus E plus Z square by R whole square minus m square c power 4 by h cross square c square into psi equal to 0. This is our original equation. We have implemented psi is equal to r of r, the first thing, again theta of theta, and the third parameter phi of phi. We have to include let this as equation 2. This equation 2 is to be included in the above equation, equation 1. So, equation 1 may be written in three different forms. The first one is we call radial equation, the second one is angular equation, and the third one is also angular, but we call as azimuthal equation. So, three equations can be generated from the first equation. So, radial equation becomes, radial equation is del square r plus E plus Z square by r whole square divided by h cross square c square into r equal to 0. This equation we call radial equation. Similarly, angular equation, angular momentum equation or angular equation is del square theta plus E plus Z square by r, Z square by r minus m square c power 4. This is also there. Z square by r whole square minus m square c power 4 by h cross square c square into theta. This is variable theta, angular equation, and azimuthal equation, the third one, third coordinate phi as del square theta del square phi equal del square phi, 1 minute, del square phi plus E plus Z square by r whole square minus m square c power 4 divided by h cross square c square of phi equal to 0. So, this is the equation 3a, this is equation 3b, this is equation 3c. So, totally we have three sets of equation. All these equations have to be solved independently and the solutions have to be merged, so that we have the final equation for energy as E equal to mc square into 1 plus nu square by lambda square whole power minus of, where nu is a constant, lambda is another constant, and lambda is mostly called as n, which is equal to n dash plus s plus 1, that is n dash plus s, n dash plus s plus 1, where n dash we call as radial quantum number. All these are quantum numbers, radial quantum number, s is spin quantum number, and n is total quantum number. So, based on quantum number, the constant lambda is to be calculated, whereas nu square we have is a constant value Z square by MC like that. So including this, we have this equation we have written as in a binomial expansion formula. Binomial expansion in the format 1 plus x power minus n formula. This is to be taken as x. So 1 plus x power minus n, which is equal to 1 minus nx by 1 factorial plus n square x square by 2 factorial minus n cube x cube by 3 factorial plus etc. It will be going on. This we call as binomial expansion. Using the binomial expansion, this E can be expanded as E equal to mc square into 1 minus n is minus 1 by 2 and x is nu square by lambda square. So we have 1 by 2 into nu square by lambda square plus n square, that is 1 by 4 nu square by lambda square whole square into 1 by 2 minus etc. It is going on. So we have simply saying mc square into 1, that we call as a naught, plus mc square into the second term I call a1 plus a2 plus a3 etc. It is going on like this. So this energy seems to be a combination of so many states, combination of many states. This is the idea given by Klein-Gordon for a bound particle, and this is the theoretical approach. When this is verified by means of experiments, experiments have shown double the value of levels as obtained from the theoretical values. In other words, theory has predicted only half the states of hydrogen atom, whereas experiments have shown many more states. Or to be very frank, large deviation is existing between the theoretical predictions of KG and the actual experiments. The deviations are mainly due to the defect in KG equation. As already told, KG equation is applicable only for spin 0 particles, not for spin half particle. Hydrogen atom, electron is a spin half particle. For that particle, if we are applying KG equation, the results are always contradictory. So we conclude that KG equation is not applicable for hydrogen atom due to its defect in formation. So this above equation we call KG equation for a bound particle. So this theoretical approach confirms that KG equation is not a full success, it is having only a partial success, and it is having its own defects in the system. So KG equation has to be rectified. That was carried out by another follower called Dirac, and we call that equation as a Dirac's relativistic equation, which will be the subject matter of our next session. Thank you. Thank you, friends. Thank you for your patient observation. And if there be any doubts or if you need any clarifications, kindly email me. And my email address is lp_dde_au@yahoo.com. You can freely email and I will definitely respond. Please give your feedback and suggestions to this email ID. Thank you, one and all.